Hello and welcome to Lesson 1. So today we're going to be talking about two different things. The first thing is going to be addition and subtraction of fractions. This should really be a review. And then we have lines and segments. And this is likely a review as well. So it should be a pretty easy day today. We're just kind of getting our feet wet and making sure that we understand some of the basics. So let's get started. This first problem, we have three fractions that we want to add together. All right, and you should recall how to do this from past lessons, but let's just kind of dive into it a little bit and make sure that we understand what we're doing. So remember, whenever we want to add fractions, the key to the whole problem is making sure that we have common denominators, right? So we need to look at the denominator, which again is the lower number. Remember, this top number is called the numerator. And the bottom number is called the denominator. And if you don't remember that, you might want to write that down in your class notebook and just memorize it, because I'll be using those terms a lot throughout this course. So again, we have our numerator and our denominator. And the first step when adding fractions is always to make sure that the denominators are the same. We need a common denominator before we can add them in the numerator. All right, and why is that? Well, let's just really quickly walk through a quick example of that. So let's say I have 1/2 and I want to add to that 1/4. Okay, and I know this is kind of going way back to grade school, so bear with me here. But let's just say that we're trying to understand why we need to have common denominators. These denominators are clearly different. One's a 2, one's a 4. And based on what I've just told you, you cannot add this until we have common denominators, until we somehow manipulate these fractions so that the denominators are the same. And let's think about what's going on here. This 1/2, if I were to draw our, let's say it's a pi, all right, what does this 1/2 mean? Well, it's a part of a whole. That's what a fraction is. It's a part of something. So if we have 1/2, the denominator tells us how many pieces we have in total in the pi. So we have 2 pieces. So we need to divide it up into 2 equal pieces. And then how many are we taking? In this case, we're taking 1. That's what the numerator stands for. So the numerator means we're taking 1 of those 2 pieces, right? So this is how much pi we have. All right, now what about this next one? So the next one is saying 1/4. So if we draw our pi for 1/4, what do we have here? Well, here the denominator tells us we need to cut this up into 4 pieces, not 2. So we cut this up into 4 pieces. I say I need 1 of those pieces. So let's say we take, this piece here. All right. So now, if we're trying to combine these pieces that we've taken, this larger magenta one here and this smaller green one, the question is, what is our solution? What is the total amount of pi that we have right here? What is this number, this fraction, as our answer? And we need to take these 2 pieces. So if we take the magenta piece and we set that down here, and it looks, something like this, right? And there's our magenta piece. And then we take our green piece and we set that kind of next to it, something like this. All right. I guess it's not quite the same color. That's all right. You get the idea. So if we set those 2 pieces there, how much pi is this? Well, we can't really talk about it in terms of halves, because it's certainly more than 1/2, but less than 2 halves, which would be a whole. And we can't talk about it in terms of fourths really either, at least not the way it's set up, because they'd have to be equal pieces. And this magenta piece is clearly bigger than the fourth of a piece here. So we need a way to describe what's going on here. And that's why we need to find common denominators first. So how would we do that? Well, this should be just, a stroll down memory lane. But we look at our denominators, which is the first one is a 2, the second one's a 4, and we have to find the least common multiple between those 2 numbers. The least common multiple. So hopefully you remember that, the least common multiple. I'm going to call it the LCM. Another good one for your notebook. Least common multiple. All right, and what is the least common multiple? The least common multiple is simply the smallest number that both of these numbers can go into without any remainder. All right, so the easiest way to do it is to take the larger number, which is a 4 in this case, and just think about, okay, what's the smallest multiple of 4? Well, the smallest multiple of 4 would be a 4 times 1, right? Other than 0, 1 is the smallest whole number that I can multiply a 4 by. So this is a multiplication problem. 4 times 1 is 4. 4 is the smallest multiple of 4. Of course, there are other multiples of 4 too. I could say, what's 4 times 2? Well, 4 times 2 is 8. 8 is also a multiple of 4. 4 times 3 is 12. That's also a multiple of 4. But the smallest multiple of 4 is going to be this guy, the 4, right? Okay, and then we can ask ourselves, well, does the other number go into this smallest multiple evenly? So does the 2 go into the 4? Yeah, 2 can go into 4, right? Because 2 times 2 is 4. So 2 can go into 4. So therefore, 4 is also a multiple of 2, because you can use 2 in a multiplication problem to get to the 4. All right, that's what a multiple is. So there you have it. So both of them have a multiple of 4. And in fact, that's the smallest number that both 2 and 4 can go into evenly. All right, so that is the number that we are going to use as our common denominator. So we need to turn this into a fraction with a common denominator of 4. And we need to turn this one into a fraction that has a common denominator of 4. Now, the second one is easy because that already has the denominator of 4, so we don't need to change that fraction at all. It stays the same. 1/4 becomes 1/4. All right? Here, though, the question is, 2 times what gave us the 4? All right? And the answer is 2. So 2 times 2 gave us equals the 4. So we need to multiply the same thing in the numerator as we did in the denominator. We multiplied the denominator by 2. We need to multiply the numerator by 2. And 1 times 2 in the numerator is 2. So we end up with 2/4. So the 1/2 gets changed into the 2/4. And now we have common denominators. So now we can add this up. And what do we get? Well, 1/4 plus, or excuse me, 2/4 plus 1/4 is going to give us 3/4. Right? Remember, when we add fractions, we do not add to the denominators. We only add the numerators. And that makes sense, because what's happening here is, let's look at this fraction right here that we changed the 1/2 into. Now we're saying we're cutting this pie up into 4 pieces. So now we have to divide it like this. Okay? And then we're taking 2 of those 4 pieces. So if you notice, I'm taking these 2 here. I'm taking the same amount as I did earlier with the magenta color. Right? Taking the same amount. So the amount doesn't change, only the numbers changed. But the beautiful thing here is now I have these 2 pieces, and these 2 pieces can fit one right here. Notice that's the exact same size as my green piece over here. At least it should be. My drawing isn't perfect. And then I have another 1/4 of a piece right here. So I have 1, 2, 3 fourths. 3/4 of a pie, which is what we have right here. We have 3 pieces of a pie that's divided up into 4 pieces. All right, so hopefully that's just a stroll down memory lane, and it maybe was very boring for you, but we need to get that out of the way and make sure that we have that in our heads so that we can make sense of some of the problems later on. All right, it's more important than you might think right now. All right, so we're gonna clear a little bit of this out of the way, give us a little bit of room. And real quickly, let's look at some of these problems here and see how you do in solving them. So this first one should be really easy. Go ahead and solve it in your head. And then I'll just pause here for a second. And then when you're done, we'll do it together. All right, so this one's very simple. All the denominators are the same, which is great. That is the hardest part to doing these problems. So the denominators are all the same, which means the answer also has to be the same. They all have to have the same denominator. All right. Then all we do is add the numerators. So 2 plus 4 is 6. 6 plus 4 is 12. So we end up with 12 pieces of a pie that's cut into 13 pieces. Okay? Very straightforward. Now let's take a look at this next one. This is similar, only now we're not adding, we're actually subtracting. But the same rules apply. So go ahead and take a second here and figure this out in your head, and then we'll do it together. All right, so here we have a common denominator again. So life is wonderful. And then in our numerators, we have 7 minus 4. So 7 minus 4 is 3. So we end up with 3, and then what's in the denominator? A 15, right? It has to be the same in all of them. They all have to have the same denominator. So there you go, 3/15. All right, now let's go to this next one. Maybe a little bit trickier. Why don't you pause the video? Try this one on your own on a separate sheet of paper, and then we'll look at it together and see how you did. All right, so here we have 5/12 plus 3/4. And the first thing is to look at the denominator and recognize that they are not the same, right? 12 is not the same thing as a 4. So we have a problem. So the first step then is to try to decide what new denominator we want. What new denominator do we want? And we need something that both a 4 and a 12 are multiples of. All right? We need to find, some number that they can both go into evenly. So I always go to the bigger number. Go to the 12. 12 times 1 is 12, just like we did earlier. We're kind of starting with that smallest multiple. So 12 times 1 is 12. 4 can go into 12, right? Think of your 4 multiplication family. 4 times 3 is 12. So yes, they can both go into 12. And that's the smallest thing that 12 can go into. So we're going to choose a 12 as our lowest common denominator. All right. Now, we have to now think about, because I'm setting this up a little bit differently than what we did over here. This is probably the more common way that you'll see it in kind of grade school books. All right. This setup where they're stacked on top of each other. When they're aligned horizontally here, this is how you'll see it more often when you're dealing with algebra. So I want you to get used to this format. But it is maybe a little bit unusual if you haven't done it this way before. So here we need to think about, okay, we're taking this 12. We somehow need to turn it into a 12. Well, that's easy. It is a 12. So in a sense, all we're doing is multiplying this by 1. All right, so 12 times 1 is 12. But that means we need to take the 5, multiply it by the same thing to get a new number over here. But again, it's just being multiplied by 1. So 5 times 1 is 5. All right, pretty easy. Now for this 3/4, we need to take this 4 and multiply it by some number to get to this 12. So 4 times what is the 12? Well, 4 times a 3 would give me 12. So that means I need to do the same thing in the numerator. So 3 times 3, same thing. 3 times 3 is 9. So I get a 9/12 over here. All right. So now I've got my numerator, I have my denominators the same. I've adjusted in the numerator. Now I can do my addition. 5/12 plus 9/12 is going to be 14/12. Now you might say, yeah, but that's an improper fraction, right? Because the numerator is larger than the denominator. That's okay. And you could also say that this could be reduced. And you're right, it could be reduced. We could reduce this, if you remember how to do that from previous years, we could reduce this to 7/6 by dividing both by 2, right? And that's fine as well. In algebra, we're not too concerned about reducing, and we're definitely not usually concerned about improper fractions. We can leave things improper, and it's not a big deal, all right? So either one of these answers would be sufficient. All right, now let's go to the next one. We have 2/8 minus 1/6. Why don't you go ahead and pause the video, try this one on your own, and then we'll do it together. All right, so again, the first step, we need to find a common denominator. We have an 8 and we have a 6. So what's going to be that common denominator? Well, if we go to the larger number and take the 8 and multiply it by 1, we get an 8. obviously. But 6 can't go into 8. So that's not going to work. So let's go 8 times 2. 8 times 2 is 16. But 6 can't go into 16 either. So that's not going to work. How about an 8 times a 3? 8 times a 3 is 24. 6 can go into 24. 6 times 4 is 24. So 24 is the one we're looking for. So we'll put 24 in our denominators. And now we just need to figure out what the numerators are going to be. So what did we multiply this 8 by to get to the 24? A 3, right? So we need to multiply this 2 by a 3 as well. So 2 times 3 is 6. And what did we multiply the 6 by to get to the 24? A 4, right? So now we need to multiply this 1 by a 4. So 1 times 4 is 4. All right, so there we have our numerators. Now we just need to complete the problem here and subtract. So 6 minus 4 is going to be 2. And of course, we're still over the 24. And if we want to, we could reduce this, divide the numerator and the denominator by 2, and we'd end up with 1/12. And there's our solution. All right? So hopefully this is very easy for you, and it's just review from previous years. But if not, that's all right. We're just, again, kind of getting our feet wet and making sure that we have these foundational concepts in place. All right. Next step. Now, what happens if we have mixed numbers? Hopefully you recall mixed numbers. Mixed numbers are where we have a fraction and a whole number, right? Side by side. So 11 and 1/2 means you have 11 full pies plus a 1/2 a pie. So what would you do if you were trying to add these up? Well, the whole numbers aren't the problem. The whole numbers are easy. That's simple addition. If I have 11 pies and then I give you 2 more, or I find 2 more pies, I'm up to 13 pies. All right, so we know we're at 13 pies, but these fractions are the ones that are the troublemakers. We need to figure out what's 1/2 plus 3/4. And so the easiest thing to do here is simply to do what we did before and kind of ignore the whole numbers until you have the fractions all figured out. All right, so I'm just going to rewrite the 11. I'm just really not going to touch it. I'm just going to leave it there. And then I'm going to take my fraction, 1/2, and I'm going to say, okay, I'm going to need a new fraction so that it has a common denominator with this second fraction. So what's a common denominator for a 2 and a 4? Well, the answer would be a 4, right? They can both go into a 4. And that's the smallest number they can both go into. So I'm going to have a 4 as my new denominator here. And then, of course, I have my plus sign. And then as my second fraction, I've got, I've got another whole number, a 2. And then I'm going to have the other fraction. Whoops. Suppose I should try to keep my colors consistent here. Whoops, it's not the right color either. There it is. Okay, so I'm going to try to keep these, I'm going to keep these denominators the same. I want them both to be a 4. And now I need to establish my numerators. So I've got a 2 turned into a 4. So 2 times 2 is 4. So I need to do the same thing in the numerator. 1 times 2 is 2. In the second one, I went from a 2 to a 2, so nothing changed. So this, I'm sorry, let me rephrase that. I went from a 4 in the denominator to a 4. All right, so nothing changed. So therefore, we can just keep the numerator the same as well. It's just a 3. And now once we have our numerator, our denominators the same, now we can concern ourselves with the whole numbers that we've been just kind of leaving to the side right now. So if we add our whole numbers, we have 11 plus 2. Well, that's going to give me 13. And then I can add my fractions now. 2/4 plus 3/4 is going to be 5/4. And again, it's improper, but we'll leave it like that for right now. So that would be our answer. All right, so let's try this next one. It's very similar. It's just subtraction instead. So once again, we have a whole number. We have a mixed numbers, which include a whole number and fractions. So we'll look at the fractions and just kind of set the whole numbers in place without really doing anything to them. So we're going to have a 7 and a fraction minus a 4 and some fraction. Okay, what denominator are we going to use for these fractions? An 8, right? So if I use an 8, 4 times what gave me the 8? 4 times what gave me the 8? 2, right? 4 times 2 is 8. So we need to take the 3 and multiply the 3 by 2 to get to the 6. All right, and then in the second fraction, 8 times what gave me 8? Well, that's just 1. Nothing changed. So nothing will change in the numerator. It's just a 3/8. Now we've got our fractions with common denominators. We can go ahead and subtract. So we have our 7 minus the 4. That's going to give us a 3. And then we have a 6/8 minus a 3/8. Well, that's just going to give me a 3/8. Right? Awesome. All right, now let's go ahead and go to this next one here. Why don't you pause the video, try this one on your own, and then we'll do it together. All right, so once again, we're going to find common denominators. So we have our whole number, just set it off to the side, and then we're going to have a fraction minus a whole number and a fraction. Our common denominator between a 2 and a 4 is going to be a 4. This 2, what did we multiply it by to get to the 4? A 2, right? So 1 times 2 is 2. The 4 was already there, nothing changes. All right, now we're ready to subtract. But there's a problem here, something that we haven't talked about yet. Let's look at our numerators. We have a 2 in our first fraction, and we have a 3 in our second one, and we are subtracting them. So 2 minus 3. If I have 2 and then I take away 3, well, that's kind of a problem, isn't it? Because we're kind of going into the hole, so to speak. If we start with 2 and then we're kind of taking away 3, well, then we're kind of one in the hole, right? So that's kind of a problem. At least at this point, it's a problem. So what do? Well, this is where we have to do, and hopefully you remember this. It's called borrowing. All right. And what we're going to do is we're going to say, okay, so this 2 is too small, right? We don't have enough in this fraction to subtract this 3 from it. So we're going to borrow a whole pi from this 6. Remember, this 6 represents, 6 whole pies. So if I borrow a pi from the 6, he's going to become a 5. Now we only have 5 pies right there. But I take that whole pi, and I'm going to add it into my fraction. So think about a whole pi. If I want to represent a whole pi by means of a 4 in the denominator, I would say that 1 whole pi is equal to 4/4, right? These two are equivalent. The second one is a fraction, but think about what it means. You're cutting the pie up into 4 pieces, and then you're taking all 4 of them, which means you're taking the whole pie, right? So 4/4 and 1 are equivalent. And that's true for any fraction where the numerator and the denominator are the same. So 8/8 is also equal to 1. 100 100ths is also equal to 1, right? But this is the one that we're going to use because we like this denominator, the 4. That's what we're using as a common denominator over here. All right. So I'm going to take that whole pi that I just borrowed from the 6. I'm going to call it 4/4. And I'm going to add it into this fraction. So I'm kind of setting that 4/4 right here. And I'm just kind of adding these two together. And if I add those two together, I now have 4 plus 2 in the numerator is 6. Of course, the denominator doesn't change. We don't add denominators. So we have 6/4. We have 5 and 6/4. That's how we could rewrite this. All right, 5 and 6/4. The beauty here is that this numerator now is much larger than it was before. Before it was a 2, now it's a 6. All right, and that's good because now if I rewrite the rest of this problem, we can see that now we can subtract the numerators. 6 minus 3, we have enough to do that. So let's go ahead and do it. So we have the whole numbers are going to be 5 minus 4, which is a 1. And then in the numerators, we have 6 minus 3, which is a 3, and our denominator, which is a 4. And there we go. All right, very good. So hopefully that made sense. This next one you know what? We're running short on time here. So I think we're going to skip this next one. We're going to do this very last one here. This kind of puts it all together. So we have three fractions. We're adding up. Go ahead and pause the video. Try this one on your own, and then we'll do it together. All right, so let's tackle this. First thing we might recognize is that this is a little bit of a longer problem. We have three fractions, or three mixed numbers that we're adding up. Whole numbers, well, they're not going to be a problem, but the fractions are the problem. So let's first find our common denominator. We have a 2, an 8, and a 5. So we need to find a common denominator for all three of them. So again, I always go to the bigger number, the 8, and just ask yourself, can the other numbers all go into an 8? A 2 can, but a 5 can't. So an 8 is not going to work. Okay, but now let's go 8 times 2. Step it up one. So 8 times 2 is 16. 2 can go into 16, but 5 cannot. So 16 isn't going to work. 8 times 3. 8 times 3 is 24. 2 again can go into it. 5 cannot. 8 times 4 is 32. Well, again, 2 can, 5 can't. And then 8 times 5 is 40. 2 can go into 40, and 5 can go into 40. So there we go. That is our common denominator that we're going to use. So we have a 40, we have a 40, and we have a 40. Make sure we get our signs right. We have a plus and we have a minus. And then we have our whole numbers. We have a 2, we have a 4, and we have a 1. All right, now let's find our numerators with this new common denominator. So what did you multiply the 2 by to get to this 40? 20, right? So we have to do the same thing in the numerator. So 1 times 20 is 20. And what do we multiply this 8 by to get to this 40? A 5. So 3 times 5 is going to be 15, right? What did we multiply this 5 by to get to this 40? An 8, right? So we need to multiply the 7 by an 8. So 7 times 8 is 56. All right, so now we have everything the way we want it. We can now go ahead and add this. And let's just quickly look at the numerators. Before we add the whole numbers, let's just make sure we don't have to do any borrowing here. The first two are fine. This is just addition. So let's just add those together. Maybe we'll do that for start. So 20 plus 15, that's 35 40ths. And let's add these two whole numbers too. 2 plus 4 is 6. So by combining these two, we get to the 6 35 40ths. And then we have this minus 1 56 40th. All right. Now again, look at the numerators real quickly here. 35 minus 46. We can't do that, right? 35 is too small. So what do we need to do? Borrow from the 6 again, right? It's going to become a 5. And then we're going to add that borrowed pi in terms of the denominator that we want. So we're going to add a 40 over 40 here. And if we do that, we have 35 plus 40 is 75 over 40. Minus 1 56 40ths. And then don't forget, we still have this 5 left over here. So there we go. There's our new set of fractions. And now this numerator is big enough so we can take the 75 minus the 56, which is what? 75 minus 56. 19, I think. 19 over 40. But don't forget your whole numbers. 5 minus 1 is a 4. So that would be our solution. Excellent. So hopefully that makes sense. All right. Now, real quickly here, let's just talk a bit about line segments. So we're getting onto a completely different subject here. But real quickly, let's go through it. So in mathematics, what is a line? And you might be saying, well, this is a line. It's just this straight thing. But then isn't this maybe also a line, or is this a line? What exactly is a line in mathematics? So a line in mathematics is actually something that you can't really measure. All right. It goes on in both directions. It's the best way we can describe it is a flat line like this that goes on forever in this direction and forever in this direction. All right. This is a mathematical line. However, bear in mind that a line is not really two-dimensional. There really isn't any width to this line. We just need to show a line, so we need to have some width, but there really isn't any width to the line at all. All right. And maybe that's more than you need to know. But basically, when we talk about a line, this is what we're looking at. And in order to be able to talk about a line, we need to kind of name a line maybe. So to do that, we'll often place points on the line, and we call these points by a letter name. So we might call this point A, all right? And then maybe we'll put another point over here and call this one C. And then maybe we'll put a point in the middle and call this one B, okay? So if we want to describe the line, we'll actually write it as line AB. We just select 2 points from the line and put them next to each other. Now, the last thing we need to do is put a line up above this with an arrow pointing in both directions. So this notation would be line AB, all right, which means the line that we see with the A and the B points on it. All right. Now, this may lead to some confusion because all we need in order to note this line is to use 2 points on it. I didn't have to use the 2 points A and B. I could have used the points A and C. So AC, the line AC, also represents this line that we see, this whole line, going forever to the left and going forever to the right. I could have also written this as BC, line BC. That also would have worked. So any one of these 3 would represent the same thing. And it doesn't have to be going from left to right. I could have written this as line CB. That would also be a correct way to do it. All I need to do is pick 2 points in the line and then just draw a line above it with an arrow on each side, and that represents this line right here. Okay? All right. Now, sometimes we don't want to name the whole line. We don't want to talk about the whole line. Maybe we want to talk about just a part of the line. Okay? And that's where we talk about line segments. So what is a line segment? A line segment is simply a part of a line, and it's usually noted as a flat line, has to be flat, and then it's going to have a solid dot on the left side and a solid dot on the right side. So the difference between a line, which is this one up here, that's a line. This is a line segment. The difference is the line segment does not go on forever in both directions. It actually doesn't go forever in either direction. It has a beginning and it has an ending. That is a line segment. All right? And what we'll often do is label these 2 dots on the end. We'll call this point maybe point A and this point B. And so if we want to talk about this line segment, we would note it as line segment AB, and we're going to have just a line over the top. All right? No arrows, just a short line over the top. And that's denoting the segment A to B. All right? Now, sometimes we might even ask, what's the length of this line segment from A going to B? If we do that, we'll just ask for AB with nothing on top. So if there's a line on top, then we're talking about the line segment AB. And if I ask you what's the length of AB with the line on top, so what's the length of this, you would say, oh, the length of that is, maybe it's 10 miles, let's just say. All right? And we could say the length of that is 10 miles, so we're going to say AB is 10 miles. It's a little counterintuitive. You might be tempted to want to put a bar over the top of this to show that it's the line segment that's 10 miles. But really what we want to write is just AB equals 10 miles. And what that means is from A to B. From A to B, it's 10 miles. All right. So just a little bit of notation here. Great. So hopefully that all makes sense. I think this is probably a good place to stop. We went a little bit over time here, I think. So go ahead and start working on that seat work for today. It should be pretty straightforward. If you have to, you can refer back to the video if you need to. And then I will look forward to seeing you tomorrow. Good luck.